This work is devoted to determining the surface fracture mechanisms of fibrous carbon composites during friction by scanning electron and scanning probe microscopy. Composites based on carbon fiber and carbon matrix are widely used in techniques where high heat resistance and wear resistance are required. First of all, as a material for aircraft brake discs, as well as in racing brakes and clutches. Composites have complex structure in which fibers are combined into bundles, and those internal layers forming composite frame. The wear mechanisms of composites generally can be divided into two main groups. Firstly, wear without surface fracture or components of the material fracture. This is the wear process with equal and constant wear rates of components. Secondly, these are various mechanisms of surface fracture, destruction of reinforcing inclusions, and their chipping from the friction surface. The wear rate of composite components will be different and not constant in time. Carbon composites demonstrate all of these mechanisms, often within the same sample of the same material. It is possible to determine by what mechanisms the material wear occurs using microscopy methods. Using scanning electron microscopy, we construct a map of the friction surface, highlighting areas of a characteristic appearance. Next, using scanning probe microscopy, we build the surface profile at the micro level, by which it is possible to determine the wear mechanism that prevails in this area. This slide shows a surface area of the composite with fibers lying in the block of matrix. The matrix in this area has less wear resistance than fibers. Therefore, during the running in, the fibers rise significantly above the matrix, although wear occurs without friction surface fracture. This slide shows the surface area of composite with fibers combined in a bundle lying parallel to the friction surface. The matrix inside the bundle is very dense, and its wear resistance is close to the wear resistance of the fibers. Therefore, the fiber and the matrix lie almost at the same level, as can be seen on the surface profile, and wear occurs without friction surface fracture as well. This slide also shows the surface area of composite with fibers combined in a bundle lying parallel to the friction surface. However, fiber spelling occurs in this area after fiber reaches a certain wear stage. This generally accelerates the total average wear of the material. This slide shows the surface area of the composite with fibers perpendicular to the friction surface. During wear process, the fiber tips that rise above the friction surface can break off. However, after this, they again begin to rise, since fibers are on average more wear resistant than the matrix is. The process, therefore, is cyclical. The profile shows fibers at different stages of the wear process, towering above the surface and lying below the surface of the matrix. Some conclusions. Experimental research shows that the mechanism of carbon composite surface fracture during wear fundamentally determines its friction and wear parameters. It is important to determine the contribution that each mechanism makes to the wear of the particular material and the parameters of this mechanism. As shown in this work, it is possible by combining scanning electron and probe microscopy methods. Thank you for your attention.